Good morning, everyone. Welcome again to this webinar of the oil spill detection use case 4 within the iMagine project. So today, myself, Igor Atake, I'm representing the consortium that is between CMCC, Orbital EOS, and University of Trento that gave this service available at iMagine Marketplace, but also at other places that I will show during the presentation. So the first thing I would like to mention is that unfortunately our spills are not a past problem. And despite all the knowledge about climate change and understanding the impacts that are linked to the consumption of oil and other hydrocarbons, it's still transported. It still happens some accidents due to poor maintenance, to bad weather, and so on. So sometimes it's not even accidents. It's mostly like on purpose. We let those things get rotten, and then eventually they will damage the environment. So just for context, I will show you these three images just to explain a little bit. So last year we had two accidents from ships that sank. One in Manila in the Philippines in July. The second one was in the Kerch Strait in the Russian and Ukrainian area. So all of these accidents spilled a lot of oil in their respective areas because the ships were transporting a lot of crude oil, and this impacted the environment at the moment and probably will impact for a long time. Not only that, we have this image from the Polinov paper 2021 that these are spills that happened in the Mediterranean that were observed through satellite. So even though there are these catastrophic events, there's sometimes oil rigs that explode, for example, in the Gulf of Mexico, we also have small oil spills that are contributing to the oil detection, to the poor quality of the water and the environment as a whole. So all of that sometimes is not seen by all of us, but it is happening. And that's why we need to keep track of those things and understand where they are, simulate, and see what we can do. So I think this was the idea of why we wanted to connect the technologies that we have for oil spill modeling and detection and do that within the iMagine project. So these three institutions that I mentioned, and today I'm only representing here at CMCC, but we work together to bring this, tackle this project and this problem within the scope of the project. So how did we aim to do and try to solve these issues? How do we can bring something to the people that can access it too as well? So from CMCC side, we are doing the oil spill simulations and the optimization of it. So we will get into further details later. And then we have for Orbital EOS, the oil spill identification from satellite imagery, which is very important so we can identify spills that are happening in areas that we are not seeing, and then we can simulate and understand the forecast of it. And lastly, but not least, we had the University of Trento creating a database generation of past oil spills that were very important for us to understand how we can further explore these events that happened so we can learn from it and then use it for future not opportunities, I would say, but incidents where we can see where we can simulate oil spill forecast. So all of that started as a base from the Okeanos project. So that was a joint cooperation between CMCC and Orbital EOS. So we had this oil spill monitoring system where we start from data into different domains. So basically we have the metocean inputs, and for that I mean currents, sea surface temperature, winds, but also we need this satellite imagery that are being collected through different satellites that are orbiting the Earth every day, every hour. And through these satellites, by using the correct techniques, you can identify oil spill, possible oil spills, leaks at the sea surface. And from these identifications, we can start a simulation using Medzlig 2, which is our model under the WITOIL interface. And from that, we have a report. So that was the idea of the project that we were working together. And then we wanted to bring that also to iMagine how we can further develop all of those things that we were doing by that time. So how we translated and adapt, of course, we could not put the whole domain into the iMagine project, but how we could improve it, how we could also make all of these things that are usually proprietary open source somehow. So for the context of the project, we start basically of identifying these oil slicks. So the code, the technology to identify these oil spills through satellite imagery, and they are using machine learning models underlying. So these are image recognitions from those imageries that are obtained from satellite. It's applied the model, and the inference will predict if there is or not oil into a certain image. And from that, we'll create vectorize a polygon around this region. So we identify precisely where we have oil, where we don't have, and from that part, we can do further experiments. So from that, Orbital US has provided us from 2019 to 2022 more or less 300 images around the world, and that we contained oil, and these images were vectorized and transformed into polygons that University of Trento was able to create a database and publish on Zenodo that today is fully available for everyone. From this dataset, CMCC trained what we are calling the ML optimizer that is using Bayesian techniques. So it's not, let's say, a traditional machine learning model where you just input a result and then you get a prediction very quick. But instead, it's a set of simulations that we improve the oil spill parameters in a way that we don't need specifically an oil spill simulation expert to set the best parameters. We let this function do the optimization. So it's a ML-driven technique, but it's not necessarily just a machine learning identification as Orbital OS did for the oil spill satellite imagery. And from that, we created a service. So we adapted the Medzlig to or what we are calling WITOIL for iMagine into the iMagine marketplace. So we have this set of images we trained with the Bayesian optimization, and then we create a service that is able to run open and freely at the marketplace. So this is more or less the overall structure. But then I will jump in now into a bit of details about each partner or what we did during the project. So first I will start talking by Orbital OS. So as I mentioned sometimes, they are the responsible for identifying these oil slicks from imagery, satellite imagery, and they have their own platform, the US viewer, in which they can provide the agreements and the scope of the communication. You can have access to these identifications from the past and to the future. So they have this business operation in which you can get into contact with Juan or either Augusto, and you can see their product. I will even show you a little bit quickly how their web page is. So here they explain how you can use the US viewer and how you can do simulations from the US viewer at the same time. So everything is integrated into their platform, their business operation. And their code is proprietary. That's one of the reasons also we don't have that into iMagine. But all of the technologies that we're using and displaying were provided by them within the scope of the project. So if you want a modern system that's up and running operationally, please enter in contact with them. And they were vital for the continuation of the project. So turning back to our presentation, Then, how we created this data set. So considering the limited extent to which orbital EOS could provide us the information, University of Toronto created a data set containing these 300 more or less polygons that I mentioned before, for which we used. And all of these data are available on Zenodo, and in which you can also open and access it with no problems. You don't need to register anywhere. And I don't know if I can click here. I didn't put a link, but I will share the link afterwards. But basically, you can enter on Zenodo, download these 300 polygons and check oil spill events that happened during these 3 years. So we have oil spill events that happened in the US, oil spill events that happened in the Mediterranean Sea, in the also Saudi Arabia. So there's a global extent that you can check for further experiments. And they also made it available in two ways, not only through Zenodo. So they are more interactive. So we have the threads, which is a system in which we can get this data directly from terminal. If you're well aware how to work with code and calling through the API, it works. And also through this web app where we can check even some simulations that were done in the past. So we will quickly jump into it too, just to let you know. So basically this is the thread server. So there is an interface, you can also access it. And here you have all the shape files available for these 3 years of data obtained. So you can navigate, you can download it, and you have also an NetDF option and JSON files option. But if you want something that is more interactive, you have their platform, which I really like a lot, in which you can explore and check all these events in a much more easier way, much more navigable. So for example, we can click here close to Cyprus, and then we have two identifications of oil spills. We have all the metadata that happened, when it happened, what was the area, the time, and you can check also all of these simulations through the catalog. So you can click here and then you inspect the simulation where it happened and another simulation that was close to it. So that was a second observation 9 hours afterwards. So all of this connection is very well done. And then I think it's a better way to explore these polygons if you also are not too suitable on using QGIS and to georeferencing tools. So all of that is done. And you can also do some, they also made available some pre-made simulations, also using Mazalik too. So here we can click the button and then you have the simulation that is moving westward. And then also the oil spills that are constrained to the coastline. So that is also an option. Of course, this is not the only one. I will show the service that is within the marketplace later. But it's a good way to explore all the data that was made available during this period. So jumping back to the presentation. Now we start talking a little bit about the optimization that we did from CMCC. So we call it the Bayesian optimization, basically because it's using Bayesian functions, or a probabilistic function that will optimize and search the better parameters for a noise spill simulation. And I have the image here at the right hand side explaining more or less the architecture, but I will try to summarize as soon as possible because it's very complex. We are also, I will show in the next slide, we wrote a paper about this methodology, but the goal is improve oil spill simulations. And how we do that? Basically, we run, right now we are setting 100 as the maximum, and we run these 100 simulations where the parameters of the simulation will be searched and we'll find the best one adequate for that situation. What are these parameters I'm always mentioning? So some of them are calibration, some of them are parameters that need to be changed depending on the context of the data that you have. So for example, the ones that we are not messing, but mixing now are horizontal diffusivity, which is the velocity in which the oil is spread into the surface, and the wind drift. So how much the wind will impact the advection, so the transport of oil into a region. So these parameters, they also depend on the data that you are inserting into the simulation. So you can have a high resolution data, you can have a low resolution data, you can have a daily field, you can have hourly fields that are very representative of the situation that is happening in that region. So that varies a lot. So that's why this system is important, because you don't need to understand all of these impacts that it can have on your simulation. You just launch it and wait for the final input, and then you have the most precise um, parameters for that condition. To the marketplace now. So I will stop sharing my screen, and then I will show how we can do it here in the iMagine marketplace. So I'm already logged in. Of course, I think it depends on how you request access to the service. Probably Ilaria can explain a little bit better how one can request and use the tools within the marketplace. But I will just guide you through what we can do with what is deployed here. So we are here, logged into my account, and over here we have different modules, and one of them is the WITOIL for iMagine, in which we can click. And then here, just before I start showing anything, into this region we have more or less the explanation and the tutorial of what you need to use the system. Because despite we making this lightweight version that can be run to the iMagine marketplace, we cannot put all the data of the world into it. So in order to have access to currents and winds, you need to register into Copernicus Marine Services and also into ECMWF Climate Data Store. So you can have the automatic download. So if you put the information here in our system, it will download automatically, but we'll use your credentials. You cannot put my credentials available for everyone. So all of this is explained here. Of course, you can also find more information in the internet. But okay, so now I think we can jump and try to use it. So the first option is to use the try button. I think the try button is the easiest one, because it will launch an radio interface in which you can launch an OSPO platform very quickly. I already did an experiment before the webinar. So sometimes it takes a while for it to load. So it depends on the availability of resources within the iMagine marketplace. And here I have a pre-made simulation. So basically this is the interface in which you can use to do a noise spill simulation. And this is the output that you receive. So right now we have the output is basically the last instant of the simulation that you called. So we are not able to show the movie, but we can show this last instant. And how you can request to obtain this simulation. So basically here, when you open a new radio, so I think it has already loaded, we have these options to change all of these buttons here, this oil spill setup and also the experiment naming and so on. So you can achieve the same results. So basically here we have as standard the experiment for Syria, which is also the one that we made in the paper that I previously mentioned. And it's a use case that is we set up here in the iMagine marketplace so anyone can test before using and performing different scenarios. So let's do another one just for you to see how. So here I'm just changing the name of the simulation and call it Syria. And this is the timeline that happened. So Also, here is the example of how you should insert a time information here. So of course you can change this to 2024, 2025, not August, because we're not still there. But I'll leave it 2021 because that was the moment where we had the oil spill accident in Syria, one of the biggest ones in the Mediterranean Sea. And here we can change, for example, the length of the simulation. You can increase it from, usually it's 24, but you can increase it up to 96 hours with no problems, and you can make also smaller. Here are the latitudes and longitudes of that accident. So if you have an accident somewhere, you find the latitude and longitude in geographic coordinates, and then you can input here, and then you will simulate that. Of course, it needs to be at the sea. We have a check to prevent people from launching from land, but it's always good to avoid that, so you don't need to don't understand why your simulation is not working. Just use the correct location. Usually you can do that on Google Maps, for example. I will drag it here. So basically, if you click here in Google Maps, and not good position, yeah, it's appearing at the bottom. Okay, good. So here, if you put a point at the sea, you obtain the latitude and longitude. So that's a very quick way of obtaining longitudes and latitudes if you don't know how to do that. And then you just substitute these values here. So that will be your spill location, that where your oil will be launching into the simulation. In spill duration, we mean the length of the simulation, so how long it will take, so how long the oil will be spilling from that point. So if you leave it 0, it means that the oil, all the amount of oil that you put in the simulation will be instantaneously released into the location. If you put 12, for instance, it means that for 12 hours, the amount of oil that you insert at the simulation will be spilled during these 12 hours. So here I have the spill rate. So it means if I put 1,200 tons, it will be spilling actually at tons per hour. So of course, ignore what I said. So if I put 0, I will be spilling 1,200 tons here. Okay. We can also change the density of the oil. So here it's we are using the standard API, which is very common in the oil spill modeling community, which translates some of the characteristics of the oil to one number. So the higher the API, usually the lighter the oil, the lower, the heavier the oil. So this is more or less the opposite in terms of higher, lower. But I will leave it 28, so we can just check. And here we need to insert the credentials that I mentioned. So for Copernicus, we have a username. So that will be my username. And then we have the password, which is hidden by default. Actually, can't change it. And you have also the token from the climate data store that you put it here. Down below, we have some additional modifications that the user can do. So it depends on the extent of area that you need of this currents and winds data. You can set the domain manually. So if you click this button, you need to change the latitudes and longitude values or where you want to crop the information. I usually don't do that because I think it's very rare that we need to specify a huge domain. We can use basically this box here, the delta one, in which we will crop a box of information around the spill location, and this delta represents degrees. So we are saying to the simulation here that we want a 0.75 degrees around our spill location, kind of like a radius, but it's a box. So we'll leave it this way, and then we will submit. Of course, the last but not least, we have the plotting limits. So here it's not blocked, it's not automatically. So depending on the location that you choose, you need to adapt this plotting boundaries as well. So I will just submit, and here you can see at the top right corner that is processing. So this has been sent to the API, and hopefully it will work. So in this case it didn't. I don't know the reason precisely, but I just used the template, and if we run it, maybe I just inserted a bad number over there, but we will obtain this result here. We will obtain the simulation at the end of 24 hours, the oil spill concentrations at that region. Okay, so we will do some more examples, and I'm showing the Gradio, but I prefer to use the API. I think the API in iMagine is a little bit more robust, so usually less errors happen over there. And this is the API. So basically I did the same thing here, and the boxes, the user inputs are identically the same, but how we can access this API. So the path is a little bit different. So here, first of all, we click don't try, and then we use this Gradio interface. However, if we want to launch the API, we need to deploy and select the API plus UI. And here we will have the deployment. So here I will call it webinar 3. And so this is the name of the application that I want to launch here in the marketplace. And it's already collecting everything that I need from iMagine. So it's collecting the container that it's deployed. And we're using the latest tag, so you don't need to change anything here. And then for hardware configuration, I always try to leave it a little bit above 8, usually using 12 for both, just to guarantee that we have enough memory for the simulation. And this is on data configuration. I think it's important also to check with the iMagine infra team, because sometimes you need to insert a Nextcloud account here just to verify. Usually we don't need it, but it's good to verify with this team if you want to launch anything here. And then we can basically submit, and this will launch a new service here. So as you can see, I'm launching the webinar 3 that I just created, but we also have webinar and webinar 2 that I was using for this previous example, so I can show you something while things are starting. So as you can see, usually if the resources are available, it's very quick to start this application. And you can also check it through the info button. So here are the info. You can see if you have anything available to go or not. So these are the webinar 1 and webinar 2. If I click on info, we have either the API button and the UI button available. So if I click on the UI, I will go to that Gradio interface, but now connected to this application. If I go to the API, I will use the Swagger API, which I just showed, but didn't explain a little bit more. So basically that's it. And now webinar 3, it's running. So just launch it, and I think it took less than 1-2 minutes to be available. And then we can also use this new UI from not UI, the one to the API from the DPass, the Swagger interface. So here in the API, it's a little bit different than what we did at the Gradio. It's a little bit more hidden as well. So as mentioned, if for example, we had a system that allowed the user to train, we could also have everything here, but we are limited to prediction. So our models are already pre-trained and they are ready to be used. But basically to do that, you just need to come to the bottom, and then you have models area, and then we have the predict under here, the last option. So we click here, and we have all those fields that I just showed. And then we click to try it out, and now we can modify it again. So we will do the test case just to see if this time it works properly. So we will not change anything here. We'll add the 0 instantaneous release. I need to add my user account. And this is the token. And that's it. So let's execute and wait for the final results. It takes about 1 to 2 minutes. So at the end, we expect to obtain something similar to this. Maybe in this example, I changed a little bit, and I did. In fact, I increased the oil spill duration. So in this case, the spill is being released for 12 hours. So we have still a connection, or it's close to the spill location. It's this cross on the map. We have the currents more that were to that frame. How are the currents in that region? So we can see here a gyre into the Syria coast, and we can also see the wind, and the wind more or less wasn't going the opposite direction of the coast. And then we can explore different scenarios. So while we wait for the simulation to finish, I had some other pre-made scenarios here in which I just tested simulation closer to Lecce, where I'm based. So here you can see that even went out of the screen. So I selected a region here. Lecce is around here. And this point is very close to the Adriatic current. So when I put the simulation here, releasing for 12 hours, this was enough to be advected very south because the current is very strong. So it's transporting this oil to the south. And I made another example. They're moving a little bit the region to this zone here at the same date. So this is 2021. So what happened into this experiment, and the result is not ready yet. So let's see if, okay, so it has just finished. And so this is the standard simulation that we usually do. And then we can check that the region is more or less the same that in the previous simulation that I did. But considering that now I just put a instantaneous release, that changes the characteristic of the more or less of the concentrations that we are seeing here on screen. So all these details in the simulation will change, and how we obtain a result at the end. The position will also change the result that we have at the end. So all of these different experiments, these hypothetical simulations that you can do, is important to test out scenarios, so you can test something that is happening into close to your I don't know, your city, or for example your study area if you are into the maritime domain. So all of these things can change the results that we have. So as I see that it didn't work for different simulation into Lecce, let's launch it again and hope it works. So right now it's setting a different scenario than we are seeing here. So I would like to change all the conditions. So here we are in 2021. Let's see if I change it to 2024 in June at noon. I will leave it 24 hours, and then we will change obviously the location. So I will change it closer to Lecce again to see what we will obtain. So this is more or less around where we are. So I will put far away from the current, so we can see if it's not being transported that quickly as we saw in the other picture. I will increase the amount of tons that we are being released. I will make it a heavier oil. We have my information here already set up. Now I don't want to change the domain that I want to crop. I basically will download everything based on this delta around that location. And then here I need to change the plot. So I will put a box around that spill location. Maybe just, yeah, I think it was too much. And let's see if it runs. So now we have to wait. what I notice, sometimes I need to close one deployment and open it again because somehow the memory is being limited. But as you saw before, it's very quickly usually to launch a new deployment. So if you wanted a new simulation somehow is not working the same deployment, just remove it, deploy a new one, and try that simulation again. So yeah, the last days, myself, my team, we did some testing, and we were able to achieve most of the simulations that we launched for different dates, different places of the world. Of course, I cannot do all of them here. We did 20 examples, but usually they work, and we achieve the result at the end of this waiting time. So unfortunately, it's also not so quick as a machine learning prediction. That is in the top tip of the hand. You just click and usually you get the result, prediction in under 1-2 seconds. But it's also quick considering that if you do a traditional oil spill modeling, if you set up everything and then try to get the data and make sure everything is working end to end, can take a lot of time. And if you do a mistake, you can just change one button here and one button there, and you might have the correct result at the end. So the goal that we had in mind when deploying things here was usability of use, of course, and this lightweight approach. So you don't need to know coding, you don't need to understand how data is being collected, but you have a quick idea of what would happen if you have a noise spill at that location. And of course, this is connected with all the previous knowledge that we gathered during the project. And that is also made available for different applications, datasets, publications. So that's more or less it. So I think I do not have anything else to say regarding the usage. That's it. So that's what we have available for the end user, and still loading. So it worked. So here we can see the simulation that I just set up. I thought I would be farther away from the coast, to be honest. So maybe I did a mistake calculating the point here. But as you can see, we have this spill location very close to the coast. And right now it's not getting this, it's not in the way of this very strong southern current that we have here. So it's not being transported into this region. It's remaining here because probably it's like shadow zone of the current. I can use this term. So this current is into this region, but is not strong enough to get into here and transport this oil southwards. So it remains into this region. So sometimes just a tweak, a little bit difference in the position that you're spinning that oil can make a huge difference to the result that you're seeing. So I think that's it. I would like to finalize here, and I'm available for questions.